during the course of the semester in terms of use of certain practices and certain tools. Any questions extending from that review for you? Yes.
Like, how many presenters are we expecting to choose between?
So, great question. So there's a larger set of projects, and they're on the order, I think, right now of 6 or 7 potential projects, which have been brought forward. I think it's 7. And then there'll be a set of presenters who will cover a subset of those projects. Not every project has a presentation available for it. Some people are out of town. Some people, just scheduling-wise, it's prohibitive for them to be here today or Tuesday. But there's a set of presenters for, I think, 4 or 5 of the projects. Remember that if any of you come with a project with a stakeholder externally and you'd like to pitch it yourself, you're welcome to do that. So it's not a closed set right now. But we do need the teams to decide by next week on one of these projects. So just bear in mind there is a stiff timeline associated with deciding so that you can get going for the first few deliverables, which include a presentation at the end of the month on infrastructure and a incremental deliverable 1 for February 8th. I did make a correction on the syllabus from the very first version and updated it. There was a switch between it had incorrectly given one date for the presentation for incremental deliverable 1 that should have been for the deliverable itself, and vice versa. And so I corrected that in the syllabus. Okay? Okay. Any other questions from that? So I'm going to be going over today these sets of best practices in a whirlwind sort of way that you're expected to apply. And we're expecting another presenter in here at some point, and I'll interrupt the presentation and we'll segue to that. Okay. So I talked last time about some of the motivations for this class. And the fact that a lot of the class is motivated by the need to address the sort of real-world challenges that arise when confronting medium and larger scale software projects. The reality of the situation is that there's a great many projects out there on the software side that encounter real problems in effective delivery of solutions. Solutions that are over budget, that are over time, or that don't have the necessary quality. And we talk a lot about this notion of the iron triangle in software. Does anyone know what's meant by an iron triangle in this context? In this particular context, what are the sort of three vertices, the 3 points on this triangle? Very important concept, and you hear it quite a bit in commercial software development. So one is time, tyranny of time. Another is cost, and another is quality / scope. Some might argue it should be a rectangle with differentiating both of those, but fundamentally it's value delivered in terms of functionality. And that can be impaired by having lower quality functionality. It's kind of buggy, it's awkward, not very accessible to those with disabilities or what have you, or to the fact there are just certain functions that are not available. So within software, we're operating within this iron triangle. And the observation is it's often really easy to have 2 of these, but it's very hard to have all 3. Given no concerns about time, I can often do things for quite low cost and decent quality. It just takes a long time. If I have no concerns about cost, I can put something together quickly with adequate quality. And if I don't care about quality and scope, well, I can cut corners and so on and come up with a really lousy site within a fairly short period of time and for lower cost. Turns out, of all of these, for reasons that I'm going to be coming back to repeatedly and recurrently in a fuguish sort of way throughout the course of this semester, quality is at the heart of all of these. Turns out that of all these attributes, quality is the most fundamental one. And this is why I care so passionately about things like design and code quality. Because if you don't have requisite quality, if you end up sacrificing quality in terms of the code base, estimates go out the window in terms of time and cost as well. Why would that be? Why would quality have such a pervasive aspect that it actually ends up impairing these other two? Yeah?
Well, if your code is buggy, then you have to spend more time fixing it.
Yeah. Good. That's one side of the equation. Anyone else? Yeah.
The size of a system and complexity increases. If the code quality is bad, then the time greatly increases.
Yeah, it explodes, particularly for larger projects. That's right. It also, on the flip side of this, it impairs your ability to deliver in a timely fashion. It also will impair your delivery to get clients and keep clients. So I've seen young startups, great ideas, fail because they didn't satisfy that first client. They're looking to that first client, that all-important first client, for the references for later clients to start getting word of mouth around. They disappoint that first client because of quality issues. You might as well write them off as a company. They're a has-been. They're also ran. Forget about it. Quality prevents ability to deliver in time. It also means it's hard to get quality people and retain them. People don't like working on, frankly, a really crappy code base. You want to attract top quality talent. You want them to feel, wow, this is a really interesting project. The code quality is up to snuff. They don't have to pull long nights banging their head against crufty code. And the costs become much more manageable as well because you're not having people walk out the door on a revolving basis, losing some of your best talent. And when you lose the best talent on an ongoing basis, you have to take those people and devote them to constant documentation and overhead because they may be lost. And how are we going to retain this knowledge otherwise? So without quality, it turns out quality is at the center in a dynamic system that's really, really quite intricate. And without quality, these two things end up suffering a lot. So quality is this special factor here that we're going to see has a huge impact on these other things. It's also the one it's easiest to fool yourself about. It's easy to know if you're over time. It's easy to know if you're over budget. Just total up your budget thus far, total up the time. But in terms of quality, it's easy to fool yourself. It's easy to not know about all those undiagnosed bugs that are out there. So this is the one where it's hardest to kind of keep track. It turns out time also, in terms of estimation, it's often, if you're just estimating the project as a whole, it'll take 3 months, and you don't really do the decomposition or break it down into pieces and estimate each of those, it's easy to fool yourself with that. But we have ways that we'll be presenting in course to do more reliable estimation involves that we can get a better estimate on the time side. So iron triangle. This is a very important concept. I wouldn't be surprised at all if that turns up in the final exam. You know about the iron triangle. Okay, so let's talk about the best practices that allow us to navigate these things, that allow us to deal with this hard challenge of addressing all three sides of the iron triangle. And why do we want to do that? Well, there's many motivations for it. Success from a commercial standpoint is one of them for many software projects. Another is to do things that are really exciting and large and innovative. If we don't have a way of managing this, we'll end up flat in our face in terms of when we try to take on the harder projects. And if we're in the commercial business, the way we'll be really successful commercially is staying at that bleeding edge, staying at that cutting edge of what's possible, And to do that effectively, you need to deal with this iron triangle. Okay, so let's talk about these best practices that let you stay at this cutting edge effectively, let you deliver solutions that are hard to deliver for your competitors, that are hard to deliver across the industry. Let you deliver those things that people will pay real money for, rather than it just being a stock job they can hire anyone with VB experience to deliver. So I had listed a bunch of these last time, and I'd like to start diving into them this time, recognizing that this is going to be going on for a couple lectures. And the first of them is this issue of risk management. So, big motivation for this. Today's risk is tomorrow's problem. What do I mean by that? Today's risk is tomorrow's problem.
Right now, it's not doing anything because it's a risk of possibility. The whole point is that
Yeah, it's merely a danger now. It's a possibility that could come about with adverse consequences, negative consequences. But if we don't deal with it, if we don't manage it, it could bite us. By tomorrow. Fortunately, folks, the reverse is true also. Tomorrow's risk is today's problem. We can learn from our experience. We can recognize that things that we see now as problems, we may see again, and if we observe it now, if we see it now, if it's happened now, we can learn from it and recognize it's likely to be an ongoing risk and more effectively prevent it down the road. So we can learn. Weinberg, in his wonderful series on quality software management, says if you don't aggressively attack project risks will aggressively attack you. We talk about Murphy's Law. But Murphy's Law has a really unrealistically fatalist view of things. When things can go wrong, they will go wrong. Yeah, if you leave the door open to them. A lot of times in life, it's like we leave our front door open in the middle of a cottage in the middle of a forest, and all sorts of creatures come in and start gnawing at our furniture. Wolves come in and chase us around, and we end up, saying, "Oh, well, why are we in such a bad situation?" Well, it's because you left your door open. We just leave ourselves vulnerable to these situations. And good risk management is one of the keys to preventing these situations. So, and at a company level, allows it to undertake higher yield projects. How many people in here have ever taken a course in commerce, in Edwards School of Business? Okay, you may have heard about this relationship between risk and return. Can anyone comment on that relationship?
higher risk means you want more return.
Yeah. Yeah, if this project is higher risk, it better yield higher return. And often those things that are high risk opportunities are associated, therefore, with higher potential yield if it works out, right? And so it is with software. You aim at a project that's really on the cutting edge because you think that's where you could get the market-leading position. That's where you can be the first mover. That's where you can reap the benefit of delivering functionality no one else can offer. And it's good risk management more than anything else, perhaps, that allows you to undertake this. And it turns out that if interpreted broadly in terms of risk management, much of this class is about risk management. It allows avoiding many problems. It allows resilience to inevitable problems. When a problem comes up, you can survive it. You have greater lead time, and you have greater unknown strategy. It allows you to bound uncertainty and helps prevent you from sort of tacitly taking over risk. So let me ask you, folks, if I were to ask in software, what are some common risks? Can you enumerate some for me? So think about from a commercial company standpoint. What are some risks for projects? Or a project in a nonprofit, same sort of deal. Give me some risks that can happen.
Requirements change.
Okay, requirements change is a big one. I like it. Another? Security issues, break-in. We've had that in 371 projects. We had a great project starting up a few years ago, and they were raring to go, making good progress, and their VM was brought down because hackers broke in, and they had left the password as a default, and it screwed up the entire configuration. They had to rebuild from scratch the VM, and they lost, I don't know, several days of work or something like that. They left the door open for it. Come on in, wolves. You know, they left the password as SA or something, secure access. They left it our admin password. So this happens, and you know, when we have risk management in place, we can react more quickly. Here's a few of them. Unrealistic schedules and budgets. We'll be talking about this. Promising too much too soon. That's a big one. Setting expectations is a lot of the key to that. Personnel shortfalls. You don't have the right people for the job. Right person walked out the door because they were disgusted with the quality, because they were disgusted with having to work long hours to deal with quality problems, because they're disgusted the customer is always unhappy with their project and they're going to want to go work on a project which is actually in a healthy situation. All those quality issues often. Developing the wrong user interface or wrong software functions, requirements misunderstanding. Gold plating. Yeah, you might think that's what Susan was talking about, but it's not. Gold plating. So here you're putting in extra features that the client doesn't actually need. So all these are about actually requirements problems. And so I like what was said earlier. Continuing stream of requirements changes. Can you start to smell the picture? You know, smell the coffee, see the picture. Many others here, but these are some of the top ones. And the fact is that a lot of projects fail. If you go look at the statistics out there, there's a lot of projects that come in over budget and over schedule. But what those statistics don't show you is the wide set of projects out there that have failed, so they don't contribute to the statistics. They don't exist anymore because they were so bad a situation they got canceled early on. And often those are not included in the stats. Okay, so what do we do to handle risk? I mean, this is a whirlwind tour. Well, we try to do risk identification. What risks are there? That's something you could start right now for your projects. Exposure analysis. How much do these risks matter? This is not about enumerating in a mechanical fashion all the risks just to please the prof. And none of this class should be about that, just to submit things for the sake of submitting or go through the motions just for the sake of pleasing me. I don't want any of that. What I want you to do is to go through these things to protect yourself. And a lot of the issue here is figuring out what risks realistically are likely to be a real problem. And give me 2 reasons a risk might not be a problem. That you could enumerate, okay, you know, there could be a giant earthquake and, you know, all the server farms maintained by Merlin and Greg and so on collapse, and you can be in a bad situation. But give me 2 reasons why you wouldn't worry about certain risks. Chance of happening is really, really low, or okay, maybe. Yeah, there's some issue of risks that can't be predicted. Unknown unknowns, Don Rumsfeld once said famously. Yeah.
It's so great that you might as well do it anyways.
Yeah. Okay. So it's kind of a given that we've got to manage this thing for other reasons. Okay, I like that. But another reason is that, okay, if it happens, yeah, maybe it's an uncertainty, but if it happens, it's something which we could readily handle. It's not something which is terribly problematic. So exposure, trying to figure out what risks are really likely to be potential problems, and then how do we handle them? And I want to delineate several steps. And these are, man, you folks listen to this lecture carefully. Those who are undergrads will be in great shape for a lot of components of the final. Okay, you can try to avoid the risk entirely. Like say, okay, yeah, you know, we're not sure. The latest iOS is really flaky, and so we'll only claim to address pre-Yosemite Mac OSs, what have you. Or you know, we won't try to handle Android 5 devices because we've heard odd things about it. You just rule it out. You can accept it and just say, look, there's not much we can do about this risk, but we'll consciously take it on and be vulnerable to it. And we're aware that this is a danger, and you document it for my sake so that I'm aware that you're taking that on. Okay, but more commonly than that, folks, you want to deal with one of a couple things. You want to mitigate it. You do something up front before it materializes that will either, and this is very important when I say mitigate, either it lowers its probability of occurring, or if it does occur, it has much less impact. So, talk about sickness within your team. Someone getting sick or someone dropping. You could have a shadowing protocol put on where people shadow each other for some of their tasks. Or you could have a lot of pair programming going on, right? Have people work alongside each other, pair debugging, so that you spread knowledge around. These are ways you invest up front to mitigate this risk. So if it doesn't lower the chance it will happen, typically in those cases, someone will get sick. But if it happens, it's smaller impact. That's one strategy. Another strategy is contingency planning. You accept that the risk may happen, but you have in place a quick strategy. Well, I'm going to say quick. You have in place a strategy you've identified ahead of time that everyone agrees on, so that if the risk looks like it's going to materialize, you kick that strategy into action. You act on it. You can act on it immediately without casting around and trying to coordinate and trying to get a hold of the project lead. Instead, you act on it right away. Okay. So contingency planning is something that can really help you. If the risk materializes, it can help minimize the damage in that case. So a famous case of this, I had a colleague who was actually in charge. He's the project manager for Statoil, a company based in Norway, that manages these larger oil rigs. And he was in charge of the project to create a multi-billion-dollar oil rig. It was being sent out to the North Sea. And they had this work being done on the design and engineering of this oil rig being done all around the world by networks of teams with CAD, et cetera. And the launch date was coming up. So he arranged for the whole launch to take place. But he got on call, in case they needed it, a couple helicopters with folks who could, they used to call them frogmen. They were scuba divers that could go down. And he had them on call. In case we need them, we can call you. And guess what? It was being launched. It got out some distance from shore, and then suddenly a plate burst and it started to take water. And the thing started to sink. Okay? They launched the helicopters. The frogmen deployed with welding gear. They welded up the underwater plate, and it saved the rig. And multi-billion dollars of potential loss. There was another rig like that was lost. I don't know if it was before or after. They lost a rig several $billion down the drain. It actually caused a minor earthquake when it hit the ground and hit the seafloor. They saved it in this case, saved the day. He had them on call. It was a contingency plan. They knew just what to do in the event of a problem. And then finally, and this is very important, risk scanning. Constantly looking out for risks that may be materialized. I want all of this to be going on during your teams through the semester. Keeping an eye out for things which may be getting out. You haven't seen this guy for a while in your team. This one is talking about way being overloaded, and he's thinking about dropping the course. These things happen. And the sooner you can kind of spot it ahead of time and identify it and bring it to the surface, discuss it, and figure out, okay, mitigation strategy, contingency plan, preferably, one of those two, the more you're going to be able to deal with this. So you're not whacked on the side of the head. As I say, Murphy's Law is very passive. It's very fatalistic in its design. The fact is that a lot of our vulnerabilities to risks, the degree of vulnerability to risk that we have is under our control. There are exceptions. There are things we just came out of the blue we don't know about. There's a huge amount of things that we actually can effectively mitigate or have a contingency plan in place if we are conscious about looking for these risks ahead of time. And as Kurt said last time, there's a lot of strategies you can undertake and be creative about this. I mean, for things that involve the tech staff, sending mail way ahead of time is desirable. Letting them know weeks ahead, not the previous day before you need something, so that they have time to put that in place just in case they're sick or what have you. Okay, I don't have time to go through these details because I want to get to something else, but I actually put together some slides on things you can do. It's sometimes recommended to have a catastrophe brainstorming session where you get together as a group and say, okay, what are the worst fears? What are the, basically unveil, sort of try to uncover risks that people may have in mind for things. How could it fail, without clear fault of one person? How could it fail being each of the stakeholders' faults in turn? Scenario identification of possible strategies. Risk exposure we quantify as probability times loss. The idea here is not to have perfection. The idea is to have a rough measure of risk. And probability is something you guesstimate. I mean, okay, so maybe it's off, but it's better than not talking about the risk at all, and it's good for reasoning roughly about it. And then sort of the loss, the degree of loss. This is what we call risk exposure, probability times loss, expected loss from this risk. And if this is reasonably high for a risk, either because probability or the loss is high, you probably want to think about trying to manage it. So what are some best practices here? Planning for the risk management, appointing a risk officer, planning, and I'm not talking a full-time position. I'm not talking about a sage who sits back every day and solely ponders the risks that are approaching. I'm talking about someone who, on a weekly basis maybe is seeking to think, okay, are there any new risks? And is talking to people in the project with the conscious desire to try to hear, okay, are there any problems that they see, any things they're worried about? This may be as varied as, this person says, I don't know if I'll be able to finish this in time for the deadline, to, this part of the code is acting really flaky for me when I'm testing it. Flakiness on that side, too. Again, we haven't heard from someone for a while, or Merlin hasn't responded to our past 2 emails about setting up that VM. So you want someone whose kind of job it is, whose responsibility is to kind of think about these things and flag them, particularly for the project manager. I would suggest updating, at least biweekly, a top 10 list of risks, so that people are aware of them and can bring up new risks if they're not on there. And having some sort of plan for each risk, some sort of contingency plan or mitigation strategy. Okay? It's a great opportunity to enhance this through postmortems, reflecting, okay, what went wrong this past milestone, this past incremental deliverable, what could we do the next time? And some people have used a risk reporting strategy. I'm not going to go into contingency planning and risk mitigation each in detail. I do expect each of these. Postmortems, particularly for the project as a whole, risk prioritization, risk officer, and an updated risk plan. I want to see that for every deliverable, a risk, an update of the top risks. And I'd like to be able to talk with you. What are you doing to manage these? I don't want to say, come to me and say, the VM couldn't be set up in time. I'm going to be asking, well, okay, when did you ask them to set it up? Were you clear enough in your specification of what you needed? You want to look in, you don't want to do a witch hunt, but you want to look into what processes, for example, are not operating properly if a risk comes and bites you out of the blue. Okay, I want to talk about assertions, although there's an even more important thing, and I thought it was here. So pardon me for just, I guess it's going to have to wait till next time. That's too bad. There's another component. Okay, so I wanted to talk a bit about assertions. This is a technical strategy. It's a strategy that some of you will have heard from me about in 214. What's an assertion? Anyone remember?
Isn't it basically that this thing is true or else instantly all
Yes.
but get out of the program as quickly as possible?
Yes. Yes, beautiful. Remind me your name.
Warren.
Yes, Warren Fair. Great. Good stuff. So the idea here is that it's an operational check on your assumptions. By operational, I mean actually while the program's running, it is checking your assumptions that they are correct. Often, folks, when we write code, we make assumptions. Give me an example of an assumption we might write. We might make as we're writing, writing a method.
I mean, something more in C++ is that the pointers we're getting are valid.
Good, good. The pointers we're getting are, among other things, non-null. Maybe they point to, still allocated objects, right? That's good. Another thing will be that, this data structure we've been given, maybe it's a hash table, has already been populated, or that it has no repeat keys in it, right? These are the sort of types of things we might assume. And an assertion checks those things while a program's being run, often during testing, sometimes when the user's using it, the program. So the idea here is an element of offensive programming. It's, look, if there's something wrong with your program, ladies and gentlemen, you don't want it to kind of hobble along and partially work and just make do. You want it to tell you as soon as possible there's something wrong so you can fix it. You don't want it to cover up a real problem with a Band-Aid in a way that hides the problem. You want to know about it as soon as possible. And there's lots of ways we do that in software engineering. And one of the most effective ways is by the use of assertions. So some of you will have seen assertions before in different languages. They're extremely simple in languages like Java and C#, Scala, more simple languages. And they'll even have a special statement often associated with them in that language. So it won't just be a call to a function. It will actually be a statement. So you assert some condition. This is some condition, that this certain pointer, person is not equal to null. And then there'll typically be what else in there? A message. A string. Such and such a method, expects such and such expects a non-null person, a non-null reference to a person, something along those lines. This would be something that you'd try to catch within that assertion in a clear way. Now, assertions often are only included in debug code, but they will sometimes make it through to user code. That varies from project to project and according with philosophy. Please, if you don't know about assertions, go read about them. You can find lectures by me online on how to put together assertions, including in C, etc. And in C, there are assert.h that you can include. In languages like Java, C#, these are built into language, but there are often compiler flags that will turn them on and off on a per module basis or across the board. Please apply assertions in your programs. I want to see your programs littered with assertions. If I see a method without an assertion, it will often raise my eyebrows. Why aren't I seeing this? Good programmers will often scatter many assertions in your code. Okay. In the final minutes here, I want to have another presentation here. Dr. Asad Al-Azem has just arrived, and he'll be talking with you about one or two project ideas. And Asad, do you need anything from this? Okay. So I'll switch this off then. Asad is coming to us from Saskatchewan TV Control, which has offices here on campus. He's a colleague that I've been honored to work with over the years, and he's also got some very interesting ideas about use of mobile technologies in areas related to TB control, to his formal job, from the perspective of someone who could actually put these ideas into use and see them helping in areas of our province, particularly in the north. So, Assad, do you want to talk a little bit? Yeah.
Was that TB?
TB.
Oh, TB.
TB, tuberculosis. Yeah.
Yeah.
Yeah.